Hi guys, I am Erin. I'm going to be helping you guys learn some geometry today. The side splitter theorem is what we're going to work on today. What that says is when you have parallel lines, the pieces in between these parallel lines are proportionate. If you remember, we talked about, I think it was in 8th grade math, algebra 1, that proportions can be set up in several different ways and you obtain the same answer. Okay? So the way I'm going to start by doing the way that I like to do it. So for the first step, I kind of see that this and this kind of look like fractions. Okay, so the way I set this up is I'm going to go 8 over 4 equals, now this is the part that you have to be careful with. This 8 is in between these two parallel lines. We need to have the piece that's in between the two parallel lines on the other side. So it has to be x, and then we're going to go over 6. Remember, a fraction equals a fraction means that you can cross multiply. So 8 times 6 is 48. X times 4 is 4x. Divide by 4, divide by 4. So we get x is equal to 12. Another way we could do this is we could say that this portion over this portion, so let's say this is method 2, 8 over x equals 4 over 6, because 8 we want to go on the same side. So now we're going to go 4 over 6, cross multiply, you get 48 equals 4x. And oh my goodness, guys, it's the same thing. Okay, here are two other ways we could do that. We could do, let's see, 4 over 6. We could do this little guy over this little guy. So 4 over 6. And then we're going to set that equal to this entire length. So we got the little portion over the big portion. So 8 and 4 is 16. 8 and 4 is 12 over 6 and x. And then we cross multiply those guys. We get 4, 6 plus x equals 6 times 12. Don't forget that this is multiple things. This is called a binomial from Algebra 1. You have to put parentheses around that so then you can distribute. So 4 times 6 is 24 plus 4x equals 72 minus 24 minus 24. 4x equals 48. And look at that, it's 12 again. Okay, another way to do that, last way, we obviously don't have to do it all of these ways when we're solving the problem. I just want to show you them so you guys can see maybe which one you like better. And then also in these next couple questions that we have, we'll see that one way to set up is a little bit easier than another way. So the last one we want to do is this guy. So let's go this portion, 8 over x, over the entire side and the entire side. So we're going to go 8 over x equals the entire length, which 8 and 4, this guy, 12 over 6 plus x. Okay, cross, cross. So 8 times, put parentheses around there, x times 12, or 12 times x, either way. Multiply that out, we get 48 plus 8x equals 12x minus 8x minus 8x. 48 equals 4, and oh my goodness, what a quinky dink, we get the same thing. If you look at these, you get the same answer no matter what. But we got easier way, a little bit more challenging, and then this one's the most challenging of them all. Very doable still, but which one do we want to use? Okay, so sometimes they're set up in pretty ways, and sometimes they're not. We gotta kind of think about it. Okay, so for example, this way we could do x over, we don't know what this little side length is, but we could figure it out. The whole thing is 25, so that little piece is going to be 25 over x. This whole, or minus x, sorry. This whole thing is 10, this little guy is 8, so then this is going to be 10 minus 8, which is 2, okay? But this is a binomial, and that's kind of like what we worked with down here and down here, so we might not want to use that piece. But if we use this whole side length of 25 and this portion of x, this whole side length of 10 and this whole side length or portion of side length 8, that's going to give us a prettier fraction to work with. So let's try that. Let's do 25 over x equals, 25 is the whole thing, so we need to do the whole thing. over the piece, cross multiply it. So we get 25 times 8 and 10 times x. 25 times 8, that is 200, equals 10x, divided by 10, divided by 10, 20 equals x. Okay, if you did this a different way, that's fine. And you got the same answer, no big deal. Like I said over here, we have 4 different ways we could do this. Okay, let's look at this next guy here. This one looks like it's set up really nicely for that way that I was showing you in the first question, where it's just fraction. So I'm going to go 9 over 6 equals 5x plus 1 over 14. So remember, the 9 and the 5x over 1, they're on the same, in between those same 2 parallel lines, so they have to go across from each other. And then 6 over 14. Sounds great. So now let's multiply. So we get 9 times 14 is 126, and then 6 times that quantity. 126 equals 35x plus 6 minus 6 minus 6. Just inverse operations, solving for x. So we get 4 is equal to x. Okay. All right, now let's look at this guy. So we got a whole length. Yes, we got a portion, the 16. We can make another whole length. That's fine. But then we're going to have a binomial with a variable in there, which I don't know if that's going to be the prettiest. So if we have this entire length of 28 and a portion of it is 16, can't we figure out what this guy is by subtracting those two numbers? So this whole thing is going to be 28 minus 16, and you get 12. Okay, so now it's going to be a little bit easier. So this is 12. So now kind of look at it, and there's your little fractions. So 12 over 16 equals 12. You want to do the 3x. Make sure you guys are doing, it's in between the parallel lines is 12, in between the parallel lines is 3x over 16 and 28. If you guys didn't do that, if you did 12 over 16 and then equals 28 over 3x, you would not get the same answer. Even though there's multiple ways to do that proportion, it's not an equivalent proportion. Okay, so we have 12 times 28 is 336. 16 times 3 is 48. So we get 7 is x on this guy. Okay, those are the examples with triangles. Just a little bit more on these guys. The side splitter theorem doesn't necessarily have to be in triangles. It could be in between a bunch of parallel lines. The same thing applies though. So like this guy, we could do 6 over 15 and then 10 over, we'll call that x, equals 10 over x. Cross multiply. 6x equals 150 divided by 6 divided by 6. X equals, let me cheat and figure that out, is 25. Okay. Okay, I'm going to make that into an x, a little bit easier to read. So we could do the whole 24 minus x here, but then you're going to have a binomial with a x in there. So let's do the part and then the whole. Part and then the whole. Sorry. Like that popped up. We'll take that away. So part over whole. So we're going to go x over 24. X, what's by it is 6. That's in between the same lines. And then that whole length is 16. Cross multiply. X times 16 is 16x. Equals 24 times 6 is 144. And then x is equal to 9. Last one. I would like you guys to pause this and see if you can come up with a proportion. And then let's come back after you have that proportion written out and see if we can agree. So if we did this entire length is x, and then there's 4. So we know that this length is x minus 4. So we could do a lot of different things, right? We could do 4 over x minus 4. We could do the whole length over 4, and then the whole length over 3 if we wanted to. So I think the one, I'll do what I saw at first, which was this, to make this into a fraction and this into a fraction. So you might have done it a different way because I know you guys listen when I said pause it and try it on your own, right? So 3 times x minus 4 equals 6 times 4. 3x minus 12. 6 times 4 is 24. Add the 12, add the 12. 3x is 36. Did you get 12? If not, whoop, you can't see what I wrote. If not, go back and see if you can find your mistake. And if you did, great job. All right, guys, that's it for side splitter theorem.